Moving on to Chapter 8, we are going to revisit quadratic equations. And in Section 8.1, we start with the square root property and completing the square. So first we'll start with the square root property, which basically just says if x squared is equal to some number c, then x is equal to plus or minus the square root of c. And it's not too difficult to see why this is true. If x squared is equal to c, then what we can do is we can take the square root of both sides. The square root of x squared we know is the absolute value of x, and we get the square root of c on the other side. And if the absolute value of x is equal to the square root of c, then x would have to be positive square root of c or negative square root of c. And we can shorten this, we can abbreviate this by writing plus or minus the square root of c. So when solving equations like this one, x squared equals c, you can do it one of two ways. You can show the work like we've done here, or you can simply use the property. Okay, let's do a couple of examples. So in problem number 1 down here, we have x squared minus 12 equals 0, and we want to solve for x. Now first of all, I want to point out that x squared minus 12 does not factor in the traditional way because 12 is not a perfect square, and so this is not the difference of two perfect squares. But what we can do is we can add 12 to both sides, and this gives us x squared is equal to 12. And so we have a perfect situation here where we can use the square root property. And so if x squared is equal to 12, then x is going to be plus or minus the square root of 12. And again, you can show your work here. Basically, all we're doing is taking the square root of both sides. That gives us the absolute value of x equals the square root of 12. And from there, x will be plus or minus the square root of 12. Now, don't forget, this is a radical, and so it should be simplified. And so remember, 12 is 4 times 3, and if we simplify this, we get plus or minus 2 times the square root of 3. In the second example, it's very similar. This is also not factorable in the traditional sense. And so what we can do to solve this equation is we can start by adding 16 to both sides. This gives us 3x squared is equal to 16. And then we can divide both sides by 3, which gives us x squared equals 16 thirds. And if we apply the square root property, x is going to be plus or minus the square root of 16 thirds. And so these are the answers, but we have to simplify this. And so we can take the square root of the top and the square root of the bottom. And the square root of 16 we know is 4. And so we have 4 over radical 3. And remember, it's not allowed to have a radical in the denominator, and so we multiply by radical 3 over radical 3. And this gives us plus or minus 4 radical 3 over 3. And these are our two answers. All right, one more here. So in our third example, which is very much similar to our second example, we can subtract 36 from both sides. This gives us 4t squared is equal to negative 36. Next, we can divide both sides by 4. And that gives us t squared is equal to negative 9. And then I'll show the work this time. We're going to take the square root of both sides. The square root of t squared gives us t, and on the other side we get plus or minus the square root of negative 9. Now remember, the square root of negative 9 is 3i. So these are our solutions. So notice that these solutions here are imaginary, and that's because we're taking the square root of a negative number. So this square root property works no matter what kind of answers we get. So it's actually really versatile. Now, how do you know when it's appropriate to use the square root property? Well, all of these problems have something in common. The one thing they all have in common is that you are missing the x term in the middle in each one of these quadratic equations. So anytime you are missing the x term in the middle, you can simply solve for the variable squared, and then once you have the variable squared isolated, you can apply the square root property. But as you know, not all quadratic equations are missing the x in the middle, and so we need to make this technique a little bit more versatile. So to point us in the right direction here, we're going to do a sort of in-between problem. In this problem here, we have x plus 3 quantity squared is equal to 25. Now, you could actually solve this problem two ways, and I want to show you both ways. One way to do it would just be to square it out. So the left-hand side is x plus 3 times x plus 3. The right-hand side is 25. If you multiply out the left-hand side, you get this equation. And then we can subtract 25 from both sides. Set it equal to 0. And from here we can factor. And once we factor, we can fairly easily get our two solutions. Now, this is the old method. It's important to understand this. And there's nothing wrong with the old method because it works. However, because the left-hand side is a perfect square, we could have used the square root property. Let me show you what this looks like. So again, we have x plus 3 quantity squared equals 25. And if we apply the square root property, we can just take the square root of both sides. And the square root of x plus 3 squared is the absolute value of x plus 3. And the square root of 25 is 5. Now, we know from solving absolute value equations that if an absolute value is equal to 5, then whatever is inside the absolute value can equal positive or negative 5. And again, this is our square root property. And then from here, we can subtract 3 from both sides. Now, when you subtract 3, you have to be careful. You have to be careful that you do not combine these numbers together. Instead, I'm going to say this is negative 3 plus or minus 5, which means we have two answers. One answer is negative 3 plus 5, which is equal to 2. The other answer is negative 3 minus 5, which is equal to negative 8. So notice that our solutions are x equals 2 and x equals negative 8. And these solutions here are the same as what we got using the old method. And for this problem, it really doesn't matter which method you use. Both methods work. However, I want to point out that this method will only work if the quadratic equation that you end up with here is factorable. If this is not factorable, then this method is not going to work. Whereas the square root property does not rely on factorability. At no point in this problem did we factor anything. So just food for thought. Okay, so for the next problem here, it says f of x equals the function x minus 3 quantity to the second power, and for what values of x is f of x equal to 18? So we have f of x equals x minus 4 squared, and we want to know when does f of x equal 18? And so if we want to know when does f of x equal 18, that's the same as asking when does x minus 4 quantity squared equal 18. So we are solving the equation x minus 4 squared equals 18. Now, if you try the old method on this problem by multiplying out the left-hand side of the equation, and you go through all the steps here, you end up with a quadratic equation that is not factorable. That means that we're not able to continue using this method. So again, that's the old method. That's the method that we applied over here. So since this doesn't work, what we can do instead is we can take our equation and we can apply the square root property, which says simply take the square root of the left-hand side, square root of the right-hand side. On the left-hand side, what happens is the square root and the square cancel out, leaving us with x minus 4. Technically, it's in absolute values. And the square root of 18, if you simplify that, is 3 radical 2. And then that means that x minus 4 must be equal to positive or negative 3 radical 2. And then the way you finish this is you take this negative 4 and you're going to add it to the other side, but we're going to put it right there in front of the plus or minus. So when we add 4 to the right-hand side, we get positive 4 plus or minus 3 radical 2. And these are our two answers. And you can leave your answers like that. That's the shorthand notation. You can also write out your answers in the longhand notation. So one answer is 4 plus 3 radical 2. The other answer is 4 minus 3 radical 2. So this is also acceptable. And finally, what you can also do is you can plug these into a calculator. And so on a calculator, if we do 4 plus 3 times the square root of 2, this gives us a decimal that is approximately equal to, rounded to 2 decimal places, 8.24. Or the other answer, if we do 4 minus 3 radical 3 over 2, we get negative 0.24. So we can give our answer in different formats, but the point is, using the square root property is very valuable because remember, we tried to solve it the old way and we got stuck. We got stuck right here because this was not factorable. So we're on to something here with the square root property. It allows us to solve equations that we would not otherwise be able to solve. So to take this technique to the next level, we need to talk about a technique called completing the square. So let's remind ourselves of the perfect square trinomial. An example of a perfect square trinomial is a trinomial like x squared plus 6x plus 9. And the reason that's a perfect square trinomial is because when you factor it, you get x plus 3 times x plus 3, which can be written as x plus 3 quantity squared. So this is a perfect square. The factorization is a perfect square. Therefore, we call this a perfect square trinomial. Now, when you have a perfect square trinomial, there is always going to be a relationship between these two numbers. And the relationship is 6 is 2 times 3, and 9 is 3 to the second power. So what these two numbers have in common is the 3. So where does that 3 come from? Well, 3 is half of 6. And so if we take half of 6, we get 3. And if we square 3, we get 9. And that relationship always holds true in a perfect square trinomial. So we can say, in general, a perfect square trinomial, which I'm calling PST here, is a polynomial of the form x squared plus b times x plus this number has to be half of this middle number, that's b divided by 2, quantity squared. Okay? Now I know this may not make complete sense in the beginning, but let's take a look at some examples down below. So down in these examples, you are given a binomial. So notice that we're given a binomial that is missing the constant term. And we are tasked with complete the square. That means we need to add the appropriate number to make this a perfect square trinomial. That's what we need to do. Add the correct number to create a perfect square trinomial. So, what number do we need to add here to make this a perfect square trinomial? So the technique is very simple. The technique is you take the middle number, which in this case is -10, you divide that number by 2, and you square the result. And this is -10 divided by 2 is -5, and -5 squared is 25. So if I want to complete the square on this trinomial, the number that I need to add to make this a perfect square trinomial is 25. Now, you don't have to take my word for it. Simply take the trinomial, x squared minus 10x plus 25, and factor it. And let's see what we get when we factor. Well, we know x times x is x squared. We know 5 times 5 is 25. And a -5 and a -5 add up to make -10. And that means the factorization is x minus 5 to the second power. So this is a perfect square. So adding 25 was the correct number to complete this square. Now, one note here is when you're completing the square, you must have a leading coefficient of 1. If you do not have a leading coefficient of 1, then you need to get a leading coefficient of 1 before you complete the square. Okay, next example, same thing. So notice we have 1x squared and then plus 3x. So to complete the square, we need to figure out what number do we need to add to make this a perfect square. So the technique is we take the middle number, which in this case is +3, we're going to divide it by 2, and we're going to square the result. And when you square 3 over 2, you get 9/4. So unfortunately, to complete the square here, we need to add the number 9/4. Now, this is a little bit harder to check, but you can check to make sure that this is the correct number. So we have x squared plus 3x plus 9/4. Let's go ahead and factor this. A little bit weird factoring with the fraction, but you know that x times x is x squared. And 9/4 is 3 over 2 times 3 over 2. And we need both of these to be positive because everything is positive here. And if you don't believe this, you can multiply it out to make sure that it gives you what you started with. Okay, and I'm actually going to do that down below here. If you multiply this, you get x squared plus 3/2 x plus 3/2 x plus 9/4. And 3/2 plus 3/2 is 6/2, which is 3. So notice, this is what you have up here. So adding 9/4 is the correct number to complete the square. Now for our last example here, we want to, again, complete the square. We have a 1x squared, so that is good. But here, our middle number is a fraction. And the technique says to take the middle number, divide it by 2, and then square that number. Well, if you have a fraction like -2/5, don't divide it by 2. Instead, multiply by 1/2. And then we'll square that, okay? So dividing by 2 is the same as multiplying by 1/2. So what I'm saying is, if you have x squared plus bx, and you want to know what number do we add to complete the square, you can take the middle number divided by 2 and square it, or you can take the middle number times 1/2 and square it. Either of those works, but when you start with a fraction, it's better to multiply by 1/2. Anyway, if we do the math here, the 2's cancel out, so this is actually -1/5 squared, which is -1 squared over 5 squared, which is 1 over 25. So the number we need to add to complete the square is 1 over 25. Now, why do we care about completing the square? Well, again, from our previous examples on the previous page, when you have a perfect square, when you're solving an equation, you can use the square root property. And so if you don't have a perfect square, you can create a perfect square by going through this completing the square process. All right, so once again, let me just remind you, if you have a polynomial like x squared plus b times x, the number you need to add to complete the square is take the middle number, divide it by 2, and square it. That's the technique. And one other reminder, this only works if you have a 1 in front of the x squared. So let's talk about how we can use this principle now combined with the square root property to solve some equations. So in our first example here, we would like to solve this by completing the square. Now, first thing I want you to notice is that you cannot factor this. Think about it. The factors of 5 are 5 and 1. There are no factors of 5 that add up to give you -14. So this is not factorable. However, we can use completing the square. So let's notice, first of all, we do have a 1x squared, so this is good. Then we have -14x, and this +5 right here is not the correct number. So I'm going to move that to the other side of the equation. When you do that, you are subtracting 5 from both sides. And subtracting 5 from both sides gives us negative 5 on the right-hand side. Okay, notice what I've done there is I took this number, which was not the correct number to have, and I got it out of the way. Now I'm going to complete the square here. So how do we complete the square? We take the middle number, which is negative 14, divide it by 2, and square that. And this is negative 7 squared, which is 49. And so this is the number that we need to add to complete the square. All right. Now if I add 49 here, remember we have an equation here. So if I add 49 to the left side, I must add 49 to the right side as well. Now the left-hand side is x squared minus 14x plus 49. And the right-hand side is negative 5 plus 49, which is 44. The significance is this is now a perfect square. So when you factor it, it is x minus 7 times x minus 7, which can be written as x minus 7 squared. See, now we have a perfect square. So we can use the square root property, which tells us x minus 7 equals plus or minus, and then the square root of 44, you can write that as square root of 4 times square root of 11, which is 2 radical 11. And then our last step is we're just going to take this negative 7 and add it to the other side. And that gives us x equals positive 7 plus or minus 2 radical 11. Those are our two answers. Okay? Now for the next problem, we're also going to complete the square, but I want you to notice, first of all, we do not have a 1 in front of the x squared. If you use the completing the square technique when you do not have a 1 here, you are going to get the problem wrong. So the first thing we need to do in this problem is we need to divide both sides of the equation by 5. And when you divide by 5, you're dividing everything by 5. And so the left-hand side becomes x squared minus 15 divided by 5 is 3, so 3x. And then minus 4 divided by 5 is 4/5, and 0 divided by 5 is 0. Now we have a 1 here, so we can proceed with completing the square. So the next step is take the number that exists here and move it over to the other side. This gives us x squared minus 3x is equal to positive 4/5. So we're adding 4/5 to both sides. Now we need to fill in the blank here. What number completes the square? Take the middle number, which is negative 3, divide it by 2, and square that. And this is 9/4. So we need to add 9/4 here, and we need to add 9/4 here. Now the significance of doing this is the left-hand side, which is x squared minus 3x plus 9/4. This is a perfect square trinomial. And the right-hand side, we're just going to add those fractions together. And you can do that by getting a common denominator, or you can do that on a calculator. Basically, 4/5 plus 9/4 is going to be 16 plus 45, which is 61 over 20. You could verify that if you want. Now the next step is we can factor this. X times x is x squared. And then if you're wondering what numbers go here, it's just the square root of that number. So that is 3 over 2. and in this case, both negative. So that's x minus 3 over 2 quantity squared equals 61 over 20. Now I'm going to take the square root of both sides. On the left-hand side, we get x minus 3 over 2. On the right-hand side, we get plus or minus the square root of 61 over the square root of 20. Let's do a little simplifying. This is plus or minus the square root of 61 over 2 radical 5. And we're going to multiply by radical 5 over radical 5, which is going to give us plus or minus the square root of 305 over 10. Okay, so what I'm doing here is I'm multiplying. Radical 5 times radical 5 is 5, and 5 times 2 is 10, and 61 times 5 is 305. So we now have x minus 3 over 2 is equal to plus or minus the square root of 305 over 10. And the final step is we're going to take this number and move it to the other side in front of the plus or minus. So we get x equals 3 over 2 plus or minus the square root of 305 over 10. And so you'll notice that these answers are really pretty complicated, and this is pretty typical for a problem that involves fractions. But again, the important thing to point out is that our original problem here, this problem that we started with, was not factorable. So there isn't another way to do this, at least right now. One final example here. We have x squared minus 4x plus 13 equals 0. Once again, this is a non-factorable quadratic equation. So notice that we have a 1 in front of x squared. This is good. We're going to take this positive 13 and move it to the other side, which gives us x squared minus 4x equals negative 13. And one thing that you might have noticed when I do this is when I move this number over, I leave a space here because I need to complete the square. So to complete the square, we take the middle number, divide it by 2, and square it. And this gives us negative 2 squared, which is 4. And so next we're going to add 4 to both sides. The left-hand side you can factor into x minus 2 times x minus 2, and the right-hand side is negative 9. And so this is x minus 2 squared equals negative 9, and taking the square root of both sides, we get x minus 2 equals plus or minus, and the square root of negative 9, remember now, is 3i. And the last step is we're going to move negative 2 to the other side, and that gives us 2 plus or minus 3i. And when you're writing this on paper, you can leave your answer like that. Sometimes when you're inputting answers like these into a computer, they will require you to type 2 separate answers. So remember, you might have to do that when you're entering your answers online. All right, that's it for this section.